Welcome everybody to this talk on People First Path to Cell-Based Architecture. We'd like to cover how we moved 60,000 people from a monolithic infrastructure to Kubernetes-native infrastructure. And how we went about that. Why does this matter? Speed. We want people able to work autonomously in their own siloed environments, and we want them to be able to progress, and we want scalability, especially in the university where we have a number of pinch points during the year where we have started of academic year, we have billing cycles, we have course timetables being released, we have students applying for courses, we have all these peaks, so it's really important for us to be able to scale and for each of the teams who are responsible for those systems to be able to respond. What to expect?
Yep. So we have 20 minutes of your time. So this is how we thought of line up the agenda. So basically we will go through who we are because we didn't introduce ourselves yet. We'll introduce ourselves and then we'll get into what is cell-based architecture and then touch based on the concepts in detail. And then we'll get into how we are using it in practical environments in an enterprise. And then we'll get into the best practices and how you can use it in your infrastructure. So that's basically the plan. And then to introduce myself, I'm Asanka Abeysinghe. I'm the CTO of WSO2. So WSO2 is a technology company that we are providing different type of middleware or infrastructure software, including API management, integration, and identity and access management, as well as we have an internal developer platform. But today I'm not here to talk about WSO2. So that's about me. And I'm the co-author of Cell-Based Architecture, the concept that I introduced in 2018. So I'll get into detail while we are going through the presentation.
And I'm Martin Jones. I'm the integration architect at the University of Edinburgh. Helped build a service layer, integration layer that all of our on-premise systems use to speak to the cloud. It's been a pleasure to work with all the different businesses across the university and get to know more about the businesses and the people behind that, and that's really driven a lot of the decisions that I've taken, and they've paid dividends as we've gone through that process. And that leads me on to, you don't build a business, you build people, and then the people build the business. It's the ideas that people come up with, it's their business processes, it's their data that underpin everything. And everything that we build on top of that just helps them to communicate that information. What is cell-based architecture?
Yeah, I'll take over from there as the creator of the concept. I think the point Martin made, like it's pretty important about people because we are in a very distracted environment, less kind of focus about people. So the concept actually came in 2018 when microservices came into the picture. Everybody was writing microservices. When you write 10 microservices, it's okay. When it becomes 100, it became a problem, and when it became 1,000 microservices, it was an issue. Then we were looking at this, and some of our customers, like WSO2 customers, were in the same category. And at the same time, if you can remember, Uber released this Death Star picture with thousands of microservices running inside the infrastructure. How to govern it, how to find the ownership of it, and how you can do a change became a that's where this concept came in. There should be a way to manage these microservices. Sometimes microservices are too granular. So how we can find that proper granularity and then group these microservices is where the concept started. And so that's how it started, and then we looked at many ways to articulate this thing. Then we found biology is a really good way to put it in as an architecture concept, and biology got cells, and cells create organs like that. It built the system. So we thought that's a really good way of looking at this problem, and that's how we started working on this. And there was another analogy came, every cell has a membrane. Then we thought use those concepts and then map it to a technical architecture. So that's how everything started, and we build this concept. So I'll getting into detail. So basically this is a quote came from Paul Fremantle, who co-authored this paper with me. So he said like these complexity that you see it in the systems, if you don't properly manage it, it's going to be a mess. So that's where we thought of we need to find a solution for this common problem. So this is the basic concept of a cell-based architecture. The atomic unit in cell-based architecture, we call it as a component. A component can be a microservice, component can be in the modern world an agent, or any workload that you run in your infrastructure that can treat it as a component. Then there's a boundary to the cell, that's called the cell boundary. And there's a communication controller, that is the gateway that you put on top of the cell. So the communication happening will control by the gateway. And in this particular concept, the gateway is a logical thing. And based on your implementation, you can have many gateways as you need it. So I'll get into the next one, that's about the communication of a cell. In this particular example, now you have 4 gateways. You have ingress that controls the northbound, which is coming outside, and then you have egress that is going out from the cell to the outside the enterprise, and then you have ingress and egress on the both sides, like the westbound and eastbound, which communicates within the organization. That is how you can control these communication. So that way now you have a boundary to that particular cell, and now you have control across all the communication that you are doing from the cell as well as to the cell. So that way you have better control. And another thing that you can apply here is domain-driven design, because most of the people, they started using domain-driven design. A concept like domain-driven design can be applied here, because you need some kind of a bounded context, and when you are defining the bounded context, you can use domain-driven design. So those are the basic concepts in cell-based architecture. Then when it comes to enterprise, I think these centralized designs are not very popular. Yes, from enterprise architecture point of view, you need some kind of centralized control. But then again, that is not the way enterprises are operating, because the communication pattern that you are implementing at the architecture level should map the communication happening within the organization. That's where a decentralized architecture with federated governance is pretty important. So you can control certain set of policies and give the autonomy for the teams to operate individually. Now, that's where the people aspect even coming, we will explain in detail. So that autonomy can provide by having this central governance when you implement the cell-based architecture, because if you visualize it, there will be number of cells based on the domains that you define running inside the enterprise. That is how you can visualize it. Martin will explain in detail with the example when it comes to how we are going to use it in the business. So this decentralized architecture with federated governance coming with this concept called a data plane and a control plane. So the control plane, you can apply all the policies, and those things will get propagated into the data plane, and the actual workloads or the cells are running inside the data plane. That is how this federated governance can be implemented. And then it's not enough when it comes to the enterprise, because a single data plane might be not enough for you to handle all the governance that you required. So that's where the number of environments are coming. So each and every environment, like dev, test, prod, staging, those kind of environments can be propagated inside the data plane and then managed by that central control plane, and all the cells will be inside your data plane. So that's a way of handling this federated governance and decentralized architecture. Yeah, I think Martin, it's about the example.
Yep. So putting that into practice, we looked at the university. So I heard Asanka speak at a conference, it was just last year, and present those topics, present those ideas. And I could immediately see how we could apply that at the university. So the university has a really strong concept of golden copy systems, golden, like the true sources of data. And that provided a foundation for me of where to draw those boundaries, where to create those cells. And those cells also aligned to our businesses. And then that automatically also gives you the realization of your business capabilities and your business capability modeling. So that seemed a really good fit. And if we're continuing with the cells, then the connections between these cells to kind of link them all together are like your synapses. And the beauty of that is then you've also got, so you've got this, these private internal connections, and then you've got control over your north-south, your public connections that you can expose. So if I go into detail and I choose, say, finance as an example, you can see at the top of this diagram, we've got a system. This is one of our transaction managers. It is responsible for pulling in all of our payment files and payment transaction files, for example, recurring card payments and direct debits from one of our payment vendors. It has an entry point in from the north, it's northbound, and it calls some of the components inside that cell. And inside that cell, we've got components like accounts receivables, we've got accounts payables, we've got a payment service, we've got a system which is called like My Finance, which is a component that specifically looks at credentials that are coming in and retrieves information. So it works like a microservice pulling personalized data to send back to the customer. So we've got all that business logic in a external application. It's calling services within that cell, and at the bottom of that cell, you can see that's going off and sending that information off to our finance system, which is an external cloud-hosted application, and there's a second external connection there out to our payment vendor. So all the logic to interact with that payment vendor is contained within a very simple microservice inside the cell as well. So we've got all these little internal connections that work very neatly. As well, on this diagram, you can see I've got those east-west connectors. So we've got other cells within our integration service that are trying to come in and interact with this data. So they would be things like our student system, other payment applications, for example, accounts payables, invoices coming in, and then there's the eastbound notification service. So that's sending that data off to applications like StuTalk. The other benefit of containing this cell-based architecture and having our components in there, so we've got very neat URL mappings. It's very easy to find. Just from knowing the URL, you're able to say, oh yes, that will belong to this component. So this is in our finance component, or it's in our estates component. The example I've got here is estates, and we had a migration earlier this year, and we moved all of our estates integrations from on-premise to a new cloud-based provider. And because we've got versioning in place, we're able to build the version that points to the cloud-hosted provider in parallel. We were able to run both versions in parallel, while all of the consumers across the university, tested their interactions with both sets of data. And then our go live was literally like 10 minutes, just flip a switch. So the sole considerations are, within my cells, I want everything to be lightweight. If there's business logic, I want to be that to be encapsulated in something that the business can interact with. So stick it in a UI. Separate your tech and business logic. Tech people want to be concentrating on delivering a service. Business want to concentrate on their data. And packaging, we're looking at how it can scale, what needs to adapt to in terms of interacting with other vendors. We don't want to scale to a point where we bring somebody else down. The benefits we see from that is very clear separation. You've got that internal security, very easy service discovery, auto-scaling, versioning, which I mentioned before, and also the separation of logs, making it very easy to view logs by component, or exposing that logs just for that one business area to the people who need to see that. Or at my level, I can see logs going across the entire organization.
Yep.
Moves us on to Kubernetes.
Yeah, so I think this conference is about Kubernetes. So how this cell architecture is meeting Kubernetes is where this part. So basically there are multiple ways. Like simple way to do is like a component can be a pod, and then you can have a namespace for the cell. So that's the basic implementation. But this is one of the implementations we have done. So there, like we use the CRDs as a way to define the cell boundary. And define the cell, and various other components in the Kubernetes ecosystem we use to like implement it. As an example, like eBPF, Cilium, those kind of stuff with various other Kubernetes components that we use. So that is how one implementation is done. But this is one way of doing it. You have the freedom, take the concept, and then build it the way that fit into your organization. Then the benefits, and then kind of the last steps. So basically, the main thing that we need to highlight, this is designed for people by people. So that's kind of the way it is. And why we are telling it's designed for people by people, because if you look at this concept of two pizza teams, there was a problem on how you define the boundary for a team. Now, this is giving a boundary for the your architecture, and this is giving a boundary for your deployment, as well as this is giving a boundary for your teams. Now, you have a clear definition. You can allocate these domains into teams. So the rule of thumb, basically, one team can own many cells, but one cell cannot be owned by multiple teams. So that way, like, you can give the ownership and then get their domain expertise and ask them to build that particular domain related functionality, and then expose them as APIs. So that's the whole concept. So that's where, like, you can use it as a people architecture, not only a technology architecture that you can write applications. So elephant in the room, where does AI fit into the this particular architecture? And I think it's driving in the correct directions. Data and then even agents are kind of going to group into these kind of concepts. So we are envisioning there are like agent cells that will package everything together, and then when it comes to RAG given, you can like package them nicely and then put it. So that's where it is fit into the more agentic enterprise. So if you look at it, there's a problem in the industry at the moment. People using different type of methods. One, like building AI outside the enterprise architecture. One, they build it outside and try to connect it as a sidecar to the enterprise. But those projects are not going well because you are not connected with the enterprise governance. And when it comes to the CISO's office, they will not allow to deploy these things and use and touch the customer data. So that's where the third, or the left-hand side picture will be really important. You have to bring AI as part of the enterprise architecture. And if you have a model or the modular architecture like cell-based architecture, it's easy to do because now you have all the APIs exposed as through the cell gateway as APIs, and now you can bring these small modules as cells into the enterprise architecture and then run it with the people that you have inside the same architecture side. So that is the advantage, that you can short circuit and bring it the new stuff into the same architecture and the deployment. So these are the contributions that we have done to this concept. First thing is the specification. You can go there. It's a markdown document. Even you can send a PR. We are happy to incorporate it because it's an ongoing document, that specification that we are keep on updating. And in addition to that, we have a reference implementation done, a product called OpenCoreo. And if you use OpenCoreo, the cell architecture is inherited inside. You are using cells to deploy and develop applications. So those are the URLs. You can go and take a look. It's open source. You can use it freely. And if you are planning to build cell architecture from ground up, then we have components coming from API management, integration, and identity and access management that you can bundle together and build a cell architecture. Again, I have put the URLs. If you are interested, you can go and take a look. In addition to that, we have 2 booths and we are there, and you can walk and come and have a chat. We are happy to do a demo as well as answer any questions.